that we have the basic rules and theorems, we can start getting what are the standard results that you previously know from Calc 1 and proving them again so that we can use them in future. First one will show if n is a natural number and f of x is equal to x to the n with then f prime of x is equal to n x to the n minus 1, right? Since we are starting in natural numbers, we don't have to worry about the case where n is 0 or negative initially, right? And the proof is relatively easy. Proof base case, proof by induction. Base case, n is equal to 1. That's really easy. If f of x is equal to x, f prime of x is equal to x to the 1. X to the 1. Prime of x is equal to 1 into x to the 0, which is 1 into 1, which is 1. So, and we have seen that f prime of x for x to the 1 is 1, right? So now assume that it holds for n is equal to k. Induction step. Assume true for n is equal to k. We want to show for n is equal to k plus 1. Show for n is equal to k plus 1. Well, f of x is equal to x to the k plus 1, which is equal to x to the k times x, right? And so f prime of x is equal to x to the k prime times x plus x prime times x to the k, which is equal to, as I have assumed it to be to hold for n is equal to k, k x to the k minus 1 times x plus x derivative of x is 1 x to the k, which is equal to k x to the k plus x to the k, which is equal to k plus 1 x to the k is equal to k plus 1 x to the k plus 1 minus 1. Therefore, it holds for x to the k plus 1. Therefore, holds for n is equal to k plus 1. And therefore, by induction, derivative of x to the n is equal to n x to the n minus 1 for every n in natural numbers. Okay, now this result can be generalized to negatives, right? And we will show that. So assume now, suppose f of x is equal to x to the negative n for n in integers. So again, we are, by saying that positive in n and negative n, we are avoiding the case that n is equal to 0. And then we get f prime of x is equal to, well, f prime of x is equal to 1 over x to the n prime, okay? And derivative of that is equal to negative x to the n prime over x to the 2n is equal to negative n x to the n minus 1 over x to the 2n, which is equal to negative n x to the negative n minus 1, which is equal to negative n x, well, that's exactly, well, negative n plus 1, whatever, if we want to write it that way. Okay, and so the same formula works for all integers. Therefore, for f of x is equal to x to the n, f prime of x is equal to n x to the n minus 1 for every n in integers minus 0. So I am saying all integers except n is equal to 0. Okay? Oops. Now, we are in this chapter going to say without proof, given without proof, we are going to use this, that derivative of sine x is equal to cosine x, and derivative of cosine x is sine x, but with a negative sign, right? So it's negative sine x, okay? And now we want to get the next major weapon that we have, which is the chain rule theorem. Chain rule. So what does chain rule say? If g is differentiable at a, and f is differentiable, at g of a, right? Then the function f composed g is differentiable at a, and the derivative, what is happening? Okay. F composed g is differentiable at a, and its derivative f composed g prime at a is given by f prime at g of a multiplied by g prime of a, right? How do we prove this? Proof. Well, what is the derivative of f prime g? Limit, f composed g, x goes to a, f at f o g of x minus f o g at a all over x minus a, right? Well, what we are going to do is going to say, hey, x goes to a, this is the same as f of g of x minus f of g of a all over x minus a, and I want to eventually get it in terms of g prime of a and f prime at g prime of a. No, sorry, f prime at g of a, right? So I'm going to multiply and divide minus f of g of a over g of x minus g of a multiplied by g of x minus g of a over x minus a, right? I'm multiplying and dividing by the same term, which is g of x minus g of a, g of x minus g of a. And now I can say this is limit x goes to a, f of g of x minus f of g of a over g of x minus g of a times limit x goes to a, g of x, oops, g of x minus g of a over x minus a. Great. Now we have a small problem. Offhand, I don't know how to find this limit. I have no reason offhand to say why this limit should exist, right? This limit is going to exist nicely because, oh, I know that f g is differentiable at a. This is by definition just g prime of a, right? So this is going to exist. What about this one? Why does this exist? And here's the crucial part. We know that that g differentiable at a implies that g is continuous at a. Okay? And so I can say, oh, let g of a be a prime and g of x be, let's say, well, this is going to be terrible in terms of writing primes, but just keep in mind that here when I say prime, I am not saying derivative, I am saying just another notation. Okay, then because g is differentiable at a, g differentiable at a implies g continuous at a, and therefore x approaches a implies x prime approaches a prime. Okay, which is, well, maybe I didn't need this, but let me keep it here. Okay, therefore this becomes limit x prime approaches a prime f of x prime minus f of a prime over x prime minus a prime times, well, that part we mentioned, that is literally the definition of g prime of a. So that is d prime of a, and this by definition would be f prime at a prime times g prime of a, and a prime was exactly g of a, so I get this is f prime at g of a times g prime of a. Okay. Let me stop this lecture here. Actually, let's do one example. Okay, so that concludes the proof of my chain rule. Example, let f of x is equal to sine of cosine of x all the way over x. Find f prime of x, right? So f prime of x is going to be sine of cosine of x all the way over x prime, right? Which by quotient rule is going to be sine of cosine of x prime times x minus x prime times sine of cosine of x. 1, 2, 3 all the way over x squared, which is equal to, well, now I have to take the derivative of sine of cosine of x, which I'll have to do by chain rule. Sine prime of cosine of x multiplied by cosine prime of x, which is, here I'm saying that, oh, I'm taking the derivative of these, right? Minus derivative of x prime is just 1, so 1 times sine of cosine of x all the way over x squared, which is equal to, well, derivative of sine is cosine of x times derivative of cosine is negative sine of x minus sine of cosine of x all the way over x squared. Okay, and I'll stop this one here. I'll do maybe one more with some examples.